Hello, so in this video I'm just going to give you a quick introduction to differential calculus and just a small idea of what we're trying to achieve when we're doing it. So you can see from this diagram here I have a picture of a car driving up a hill. Now I want you to imagine that this car is driving at a completely steady speed. So it started off say at driving 10 miles an hour and it's just going up the hill. So what we're doing is we're charting how high it travels per second. So after 1 second, it'll have climbed a distance of 10, we'll say 10 feet or 10 meters, whatever you want to think about it. It's not too important. But for this one, say every 1 second, it'll travel 10 meters. In 20 seconds, it'll travel in 2 seconds it'll travel 20 meters and so forth. You can see it's rising at a completely steady pace. So what we're trying to do is just to track the rate of change here. Now you can see that the rate of change here is completely constant. It's moving at a completely constant speed. Now you know in real life things don't always move in a completely constant speed. They change. Sometimes the car could be accelerating, it could be slowing down. In what way could we track that rate of change? Now, just to relate it to this one, the rate of change here is simply actually just the slope of the line. So if you look back to coordinate geometry, and you can see your slope will be your rise over run. So it will be 1 second here, which is your run, and it will rise 10 meters. So your rate of change there is 10. Now, what if we looked at another example? So that's something we wouldn't need calculus for. But say if we came over to this example here, imagine if I was standing on the ground and I had a ball in my hand. So I'll just draw a picture of myself there. So as a person standing there and they take a ball and they throw it up along this path. The ball rises up in the air. When you start to throw it, it's going at its fastest speed. So it's accelerating, or not accelerating, it's traveling fast, and it starts to slow down as it starts to rise. Slower, 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 slower. And then right here at this point, it's going to hang in the air for a second, and then it's going to start to fall down again. And you can see as the ball falls, because of the effect of gravity, it's going to get faster and faster and faster as it goes to the ground. And since it's traveling faster, the height difference it's going to change is going to be different as well. So if we think here it's going to be having a maximum rate of change. So it'll be going, actually we can think of this in terms of, if you looked at the slope of that line earlier, what if we were to take a line, say if we just took a point like that and we just drew a tangent line. So a tangent, the same as a circle. It's something that just touches it at one point. So a tangent to this, that would give the rate of change at that exact point. And you can see that as it's going up here at the bottom, it's got a really high rate of change. So you can imagine this will have a high slope because it's going up. And then as we go further and further up to the top, you can see the rate of change is going to be slow. And that's going to be indicated by a smaller slope of that line. And then you can see at the very, very top, something that's straight across like that is going to have a slope of 0. So there it's not changing height at all, just at that one particular second. And then as it's coming down here, it's going to start to slowly fall. And then it's going to start to speed up, and you can see our slopes are changing. So just a quick reminder of slopes. You remember up here, it's going to be a positive slope. So that means it's moving in a positive height. And then when it comes down here, it's going to move a negative slope, like so. And then if you take a negative slope like that, and then you just push it down a little bit further, that's going to be changing at a faster speed. So this can be used to measure loads of different things. Like if you think of the acceleration of a car, the movement of a rocket through an air or anything, it's not just limited to this example, but this is just a basic idea to get you started with the concept of what we're trying to achieve by learning differential calculus. So in the following videos, I will show, in other videos, I'll show more examples of how you can actually do this and how you can calculate the rate of change at an individual point.